Today I'm going to go over method number 2 for solving exponential functions, which is to rewrite the exponential using the log or ln. So up here it says the first step is to isolate the exponential. Then if we cannot get common bases, so if you remember that was method number 1, common bases, then we can just rewrite with logs instead. So in practice A right here, first thing I need to do is isolate the exponential. Remember, the exponential is the base raised to the power. So in part A here, our exponential is 5 to the x. So my goal right now is to isolate it, kind of like solving for it. So if you remember, when we're solving or isolating, we do order of operations backwards. Some of you have called it SADMEP. So we're going to subtract the addition first. So plus 3, I'm going to subtract 3, and I have to do it from both sides. So I get 2 times 5 to the x equals 6. All right, now I need to finish isolating it. I'm going to get rid of that multiplication by 2 by dividing by 2. I can't touch the 5x, so that's why I need to just move everything to the other side. And I get 5 to the x equals 3. Okay, at this step, I cannot get common bases between 5 and 3. So my next step would be to rewrite as a log. So remember, rewriting from exponential form to log form, we always start at the base. The base of my exponential here is 5. That will become the base of my log. So log base 5 of 3 equals x. All right, now that I have it in log form, your next step depends on what type of calculator you have. If you have a calculator that can do any base, you're set to go ahead and plug this into your calculator. But if your calculator does not, then we need to use the change of base formula. Okay, the change of base formula would change this log into the log of 3 divided by log of 5. Remember, this change of base formula is only necessary if your calculator won't do this other types of logs. And when I plug that into my calculator, I get 0.683. And that is x. If you're a little bit confused about change of base, there is another video that goes over that you should check out. All right, let's try B. So in B here, first thing, determine what is the exponential so I know what to isolate. And here, it's the 1/2 to the x power. So next thing I need to do to isolate it, I'm going to do addition or subtraction next. So we will add over the one that's being subtracted. And I'm left with 3 times 1/2 to the x equals 5. Next step, I will divide by the 3 so that I can get the 1/2 to the x power by itself equals 5/3. And I cannot rewrite 1/2 and 5/3 as common bases, so I'm going to switch to log form. Again, starting at the base of the exponential, that will be the base of our log. Log base 1/2 of 5/3 equals x. Again, I'm going to use change of base just so that I can plug it into my calculator. Remember, with change of base, you can change it to log or ln. It's totally up to you. ln is just less letters to write, so I'm going to use ln here. So I'm going to do the ln of 5/3 divided by the ln of 1/2. Again, just because my calculator won't do the log base 1/2. And I get negative 0.737. All right, let's try another one. Here in C, my exponential base is 12 to the power of x plus 2. So that x plus 2 is included in the exponential because it's in the exponent. So there's actually nothing with our exponential. It's already isolated. So we're ready to switch to log form. Starting with the base of 12, so we get log base 12 of 6 equals the exponent x plus 2. All right, I'm going to simplify the log next. So that would be ln of 12 divided by ln of 6. Just because my calculator doesn't do it, you can plug it in if your calculator does. I'll say that every time, just so you know. 1.387 equals x plus 2. If your calculator does do the fancy bases, you should be getting the same answer as me, though. But now we need to finish solving because right now I still have x plus 2 and I need to have x equals. So the next step would be to subtract 2 from both sides. So 1.387 minus 2, and I get negative 0.613 equals x. And there's our final answer. All right, let's try D. In this problem, 3 to the x is the exponential that I need to isolate. So in step 1, we're going to divide both sides by 2. And I get 3 to the x equals 11. Now that the exponential is isolated, I'm ready to switch to log form. Starting with the base of 3, I get log base 3 of 11 equals x. All right. Just because my calculator is not fancy, I need to use change of base. So we'll do the ln of 11 divided by ln of 3. Don't forget to close that parentheses when you first type ln of 11 before you type in ln of 3 or the division symbol. And I get 2.183, and that is x. All right, in letter E here, we have an E. So in this problem, the exponential is e to the 0.05x power. Remember, e approximates to 2.7, but we will leave it as e. We don't want to round. Step 1 is still to isolate the logs. Oh my gosh, it's not a log. E is not a log. My first step is to isolate the exponential. E is exponential. All right, so I'm going to divide both sides by 2. And I get e to the 0.05x equals, we just leave it 45 over 2 for now. All right, at this step, I cannot get common bases, so I need to now switch to logs. So we're going to start with our base of e. So I'm going to have log base e, which is ln, of 45 over 2 equals 0.05x. Now in this one, we already have ln, which our calculators can do. So we'll do ln of 45 divided by 2. Equals 3.114 equals 0.05x. Last, I'm going to divide by 0.05. And I get, oops, I should probably show my work here. I get 62.28 equals x. And there's my answer. All right, in F here, the exponential that we have is 4 to the x plus 1 power. All right, so the first step is going to be to add 7 to both sides. 29 plus 7 is 36. So I get 3 times 4 to the x plus 1 power equals 36. Next step is going to be to divide both sides by 3 to continue isolating the radical. Oh my gosh, radicals. It's a little too late at night for me, guys. I'm doing my best. So to isolate the exponential, all right, now that I've got 4 to the x plus 1 power equals 12. Now it's time to switch to log form. So I'm going to start with my base, which is 4. We've got log base 4 of 12 equals x plus 1. All right, again, my calculator's not fancy, so I need to use the change of base. If your calculator's fancy, you get to skip this step. And now I'm going to plug it in. ln of 12 divided by ln of 4 is 1.792 equals x plus 1. Finally, we need to solve for x. So I will subtract that 1 over, and I get 0.792 equals x. All right, 3 more problems. I'll get through them all. I might move a little bit faster on these 3, but we are still doing the same steps. First, isolate the exponential by adding 3 to both sides, and I get 8.2 to the x plus 1 equals 55. Don't let that decimal scare you, because we're still going to do the same thing. We start with our base, log base 8.2 of 55 equals x plus 1. We have to change to logarithmic form. Now that I've switched, I need to use change of base. You might not have to use change of base if you've got a fancy calculator, but I do not. So I'm going to do the ln of 55 divided by ln of 8.2, and I get 1.905 equals x plus 1. Now, finally, I have to finish solving for x. So we're going to have to subtract that 1 away so that I get x isolated. And I've got x equals 0.905. All right, H, we have another problem with base E. So we've got our exponential here. It's time to isolate. So I will first start by adding 1 to both sides. Remember, you isolate by doing order of operations backwards. So that's why we start with the addition, and now we go to the division. Now that I have the exponential isolated, it's time to switch to log form because I can't get common bases. So we're going to start with our base E. So that's going to be log base E, which is ln, of 3 over 4 equals 2x minus 1. Now in this problem, ln of 3 over 4, that one is already in a form my calculator will do. So I get negative 0.288 equals 2x minus 1. And now I need to solve for x. All right, first thing I'm going to do is add 1 to both sides. And I get 0.712 equals 2x. And the next step would then be to divide by 2 so that I get 0.356 equals x. And we're solved. All right, last problem I. Again, here we've got another E, so this is some good practice with E. Step 1 is to isolate the exponential. So I need to start by getting rid of this 3 out front by dividing. Since 3 is being multiplied, I can cancel it with division. So I get e to the 4x equals 8. And now it's time to switch to logarithmic form. So I start with my base, which is e. Log base e is ln of 8 equals 4x. All right, this time I can plug ln of 8 in my calculator, and I get 2.079 equals 4x. Now in this step, I need to finish isolating x by dividing both sides by 4. and I get 0.51975 equals x. And there's our final answer. Now, method 2 is good when you can't get common bases. Even if you can get common bases, sometimes you can still use this method. Not always, but sometimes you can. So this is an important method to know.